5. 5 times 5 is?
25.
Yeah. Hey folks, welcome. Yes, welcome out there. You know, some of you are still out of school, aren't you? I'm in school here today with you in Mathline. I'm Ernie Roberts. I'm your host. And we want you to call us in this afternoon. I'm your host for afternoon session of, you got it, Mathline. For those of you who've never been to Mathline before and you're just kind of, scanning through those channels, you surfing the remote with it, all those good things, we answer math problems. We work them out live together on the air. You call in, we'll talk, all right? Also, it's pretty straightforward. We got an operator that's going to take care of getting you to me, and then we'll work the problem together in the air. Oh, what you got to call? Oh, yeah, that number, 844-686-2378. We love it when you call, you make the show rock, and it's a lot more fun to talk to people rather than just talking out there at you, okay? So give us a call, folks. Any ages, all are welcome. We want to hear from you, 844-686-2378. Get us primed off a little bit here. Let's take a look at today's problem of the day. We have a tree casting a 30-foot shadow. Ooh, that's fun. While a nearby flagpole casts a 24-foot shadow. Wow. If the flagpole is 18 feet in height, how tall is the tree? All right, let's take a look at some of the elements of this. It sounds like a lot of stuff going on here, but it's not that bad. It really isn't that bad. Now, here's what's going on. The key word nearby, say, what's that about? Basically, we're talking about the sun being in the same place with the same angle, so it's going to put these shadows and objects into a proportional setting, all right, because we're getting light conditions here. So thinking about it, I've got a little ruler in my hand. Let's see if I can draw kind of an idea here. These are going to be stick poles and stick people or stick trees or whatever, all right? So just be patient on it here. But we're going to have basically, you've got a tree back here casting a shadow down, oh goodness, of about 30-foot shadow, we'll say. There's 30. And we got a tree that's running perpendicular because that's usually how they grow. And the question is it higher or lower or whatever? I guess we need to look at our other piece before we deal with this. Let's take a look at the flagpole, what it's doing. Flagpole shadow is not quite as long. But we have a definite height on that flagpole, and it looks like it's shorter than the shadow. All right, so let's pull it back just a little bit here. Oh, see if we can get it straight. Pull it back there, all right. And we're going to give it a right angle here. Now this one over here is a little bit taller. I don't know if I lined them up perfectly. Sorry about that, my friends. Come on, little. All right. And we'll box it there. And actually that shadow goes out a little bit longer, doesn't it? We'll play that. All right, so this is 24. We'll send it out just a little bit more too. And we'll send you up just a little bit higher there. All right, now we can make a triangle here, but the basic idea here is this is our flag. We could put a little flag up there. And this is our tree. We'll put a little bit of foliage on there. We are wanting to know how tall is the tree because we know this flagpole has been measured to be 18, and these are all feet, by the way. Feet. And there's 30 feet. So the question mark is just what's going on over there. How tall is the tree? And because it casts a longer shadow, everybody should already have the idea, oh, it's got to be taller, doesn't it? Because the sun is basically shining down in the same angle there, and we're getting basically the same effect on the shadow, all right? So you got the flag, and we're going to say from the zenith of it, where it is, where's that top point there, all right? So as we look down there, this is what's kind of casting down the shadow there, and we do have a similar triangle because we got proportional sides, and we got a right angle in between. So it's kind of a little side angle side similarity going on for those of you who like that geometry backing up question here. Now, let's concept what's going on here. Let's just call it X. Why not? I like to make proportions with X involved there. So you go, oh, there goes that algebra again. This is easy algebra. We're going to say, got a couple of ways we can work this one out. I'm going to start with X to 30. I'm going to basically talk about the real deal to its shadow. All right, so in this case, this is the tree to the tree shadow, X to 30, okay, X over 30. So I started that, I've got to stay in the same format. So this one is going to be also object to shadow, which in this case is a flagpole, and its shadow is 24, so it's going to be 18 to 24. Now you see where we're going. Got it going. We've got it there, right? And at this point, it's just a simple cross multiplication. And we hope that it will come out some semblance of being even. Let's find out what happens, all right? Cross multiply. Take the extremes together. That's 24 times x. Gives us 24x. That's pretty straightforward. Go with the extremes. And 30 times 18. Sorry about that. Did I call those extremes? Those are the means. Those are the means. So let's see what we're going to do when we multiply 30 times 18. So again, those are our means. Our extremes were what I said, 24 and x, so we don't want to mess up on that. Terminology is important stuff too. And we've got 540. And I got 24x. Now, I don't think 24 is going to divide into 540, quote, evenly as an integer. However, let's see what we do come up with. So let's go back to the calculator here, and let's see if we can't at least come up with maybe a half or a quarter or something like that, which would be nice, which would be really nice. Let's see where we're going. I get 22 and a half, and that is in feet, by the way. So 22, we'll put a 0.5 on there for those you like 5/10, and that is our feet. Now, does it make sense? This ratio, folks, is a 3 to 4. If you were to take 18 over 24, you could reduce that down to 3/4 exactly. I bet someone's going to call in and say, could you have divided by 6 on those to begin with? Yes. But when you're cross multiplying, you got a calculator, you can just go ahead and hit it headlong. But the ratio should be the same for both of these. That's why we say it's in proportion. Ratio is the same. So over here we've got 22 divided by 30. Now, question is, does that give us 3/4 or is it a decimal? 75/100. Let's check real quick here. 22.5, we'll divide that by our 30, and we should get, 75/100, which is 3/4. So that's an easy, quick check on it. One more quick note on this before I shut you down on this. What if I had said x over 18 equals 30 over 24? Another way we could work that out. And you would still get the same thing when you cross multiply. Your x would have shifted over into a mean position, but you're still going to have 18 and 30 lining up as well as 24 and x. So again, as long as you set your pattern and stay with it, you can set up a proportion more than one way and still get to the right answer. If you mess up and change the pattern, you will definitely have a bad answer. All right, so take that to the bank and use it. And that's your problem of the day. I hope you enjoyed it there. And let's go to a caller waiting for me. Welcome to Mathline this afternoon. Who am I talking with?
Emily.
Emily, good to hear from you this afternoon. Emily, where are you calling from? What city or what county?
Tennessee, Knoxville.
Knoxville, great. Glad to have you with us this afternoon. What can I do for you?
Well, I have this problem that I was thinking of that got me stuck.
Okay, yeah, let's go for it.
Okay, so it said that Emma needed art supplies, and if a paintbrush cost $1.75 and she needed 10 of them, how much money would she need?
Okay, so she's going to buy 10 brushes, and hold on just a second, they're $1.75 each?
Mm-hmm.
Okay, all right, keep going.
Well, and then I know that if you multiply anything by 10, all you really have to do is add a 0 to it, which I tried that, but all it really did was mess me up.
Okay, all right, so let's just kind of, let's take that point back just a second. If you multiply by 10, okay, and I'm going to use, since you got $1.75, right? So if you add a 0 to it and don't shift the decimal, then we've got a problem.
Mm-hmm.
Because for one thing, you're still going to get $1.75, aren't you? Just adding a 0, that didn't change the value, did it? Because you still got this decimal sitting. You see what I'm talking about? You still got this decimal sitting here. So let's think about what went on here. First of all, let's just multiply it out, okay? And when you say you're going to add a 0, it's going to be right down there. And we're going to multiply 5 times 1, which is going to give us, well, guess what? 5, 7, and 1, right? How many decimal places do we have to count off?
4.
No, we don't have any decimal places here at all, do we?
Oh, no.
You see? 1, 2, right? You with me?
Yeah.
Because we have 1, 2 places, right? Right here. There's none in the 10. That's a whole number, right? So we're going to count 1, 2 places in there, and that gives me $17.15. 50 cents, not 15, but 50. Does that make a little more sense to you?
Yeah.
Okay, so the thing is, basically, when you multiply by a power of 10, the decimal is shifting. Now, let me go to this point. Let's say we just had, for some reason, 175 times 10.
Mm-hmm.
That's when you would add the 0.
Yeah.
That would give you, because there's no decimal counting off, is there?
No.
And that's the thing. So anytime you multiply by 10, really what's happening, you're shifting that decimal over a decimal one place. If you multiply by 100, guess what? You would shift it over 2 places. Do you see how that works? Does that make sense? And it's not as, hopefully that clears up whatever was going on in your head. And I appreciate you calling about that, because a lot of times people hear a little rule and they don't take the whole thing to the mind, what's going on there. Because if you add a 0 to a decimal, guess what? You are right back where you started, aren't you?
Yeah.
Okay, does that make sense to you?
Yeah.
All right. Well, thank you for calling in this afternoon, all right? And
thank you for helping me.
Sure thing. No problem. Thank you, Emily. And again, folks, those are some of the, sometimes it's just a little simple moment that hits the light bulb, and it's awesome when that happens. So give us some calls, all right? 844-686-2378. It's just as easy as what Emily has done. We take all ages, all questions, and we'll try to solve it together live on the air. Now, speaking of which, the infamous problem of the week is back, because we're planning on being here all 4 days this week, even though I know a lot of folks are out of school today. We're out of school yesterday, and probably will be some out tomorrow. Who knows? But what we want to look at, let's take a look at our problem of the week here. Get it set up for you. It's long, isn't it? Oh my goodness. This is also published on Facebook. You can catch it there if you don't catch it all from here. But let's just talk this thing through. We got 3 angles involved. They are all congruent. By the way, congruent means they have the same measurement, the same amount of degrees. The first angle is, oh my goodness, it's algebra, isn't it? It's 2 variables even. Oh goodness, we are making y'all work today, aren't we? 3x minus 4y. All right, write that one down. That's an angle. First angle. Second angle is x minus y. And the third angle is y minus 10. So I'm going to make this a little bit more cohesive. All right, let's go to the paper here and see what we got. I'm going to go ahead and tell you, and this is my hint for today. Remember, we work these things out throughout the whole week, and Thursday I'll reveal the final solution. But the first angle, we're going to put m angle 1. That means measure of angle 1. It's going to equal 3x minus 4y. All right, that's our first start here. We're going to pick up measure of angle 2 to make this a little bit easier, because a lot of times people just get nervous about all those words. They aren't that bad. It's going to be x minus y. The other story, the third angle, equals y minus 10. Now, what are we looking for? We're going to find x, we're going to find y, and we're going to find the angle measures. Now, some of you are already saying, but Ernie, we have no equations here. That's part of the problem of the day. We need to come up with at least what? To solve with x and y, we've got to have at least 2 equations that have x and y involved in them. Now, go back to this first hint, because this is the powerful moment right there. Congruent angles, they're all 3. All 3 are congruent. So I'm going to give you a hint. This is your hint for today. We're not going to go much further than this. One of those equations that you could have involves the fact that measure 1 is equal to measure angle 2. All right, there's your first clue, as I'll say. Second clue, how about it? Maybe measure angle 1 could equal a measure of angle 3. And now you tell me, what's the third one? Of course you can't tell me. You're shouting at the screen, right? How about the measure of angle 2 equals the measure of angle 3? There are your 1, 2, 3 options. All you need are 2 of those. You pick which 2 you like. I'm not going to give you 3 different solutions. We'll pick 2 on by Thursday, but we'll go ahead and fill in some details. But you've got all the information you need right here. And then we'll see what we go with that tomorrow, okay? How we get that to simplify. Then leave it with you to have it Thursday. We'll finish it off. How's that? Everybody good? Nod your head out. Of course, you're nodding your heads. Thank you. And that is our problem of the week. So again, we will add a little bit of a hint every day until we get this thing solved, all right? And by Thursday, we'll have it cranked out. And you'll know what x and y, and you'll know the degrees of each angle. By the way, they're all the same. And I'll go ahead and give you a hint. They are not all 30 degrees like being a right angle. So you can't just throw, well, you may want to try just throwing numbers in there for each of those. It'd be very hard, okay? try to work it out with a good old algebra moment there, all right, and see where it's going. Yesterday afternoon, I had a inclusion symbols, and someone called. One of our adult viewers called in, and I appreciated the question. It was really a lot of fun. He was asking about, and we didn't get him on the air because I think he went ahead and disappeared from us. He was asking something about, could we have used absolute value parts? So let's take a look at this problem, what we had yesterday. And we worked out, this was a bad way, this was no good, this one was good, this one was not good, all right? So this was the one that actually worked. We were trying to figure out, where do we put inclusion symbols, which are our parentheses. Now, gentlemen ask, could you have used absolute value bars in here? And I'm going like, whoa, now that's an interesting idea. And the truth of the matter is, if you had put absolute value bars right here, you would have had another way of doing it. Now, usually we do not think of, let me pull that down just a little bit there, guys. All right over here. And you would have kept 5 minus 3 squared inside the absolute value bars. Usually we just don't think of those as being inclusion or in grouping symbols, but yet it would tell us that we would take care of that and we would have to do the absolute value of that. So I give that a good viable answer, all right? That's some thinking outside the box. I liked that. Never thought of that because all the time we're thinking of parentheses and brackets, like I said. But with absolute value bars, certainly it would work. Here, you already had it working. You could have put them in there. It really wouldn't have made any difference. But on this one, you could have pulled that back to a positive 40 and made it a correct situation if you put those absolute value bars. Food for thought out there. And as I say, my thought process on putting that problem together when we had it, because it has some interesting twists and turns anyway, was not even thinking about the absolute value, but good thinking. I don't know who the person's name was. They called in and left that information, and I said, I'd address that today because I understood then what they were trying to tell us there. So sometimes when I don't hear it personally, I don't know what they're asking, but that was an interesting twist on that. I like that. I like that. So anyway, speaking of which, people do call, and we do love to hear from you. So 844-686-2378, magic phone number. We want to hear from you. Give us some calls here. Any age that you want. Okay, and also, by the way, we had mentioned earlier a little bit about Facebook. That's where you can see our problem of the day. And if you want to get that problem of the week down really good, it's printed up there also. And that is at facebook.com/Mathline Online. Like us there, love us, and above all, share us. Share the problem of the day. Share the problem of the week with all your friends and all your relatives and all your neighbors, even your enemies, all right? Share, share, share all over the place, all right? And of course, right now, give us a call, 844-686-2378, because that's really what we're about today. YouTube, did I mention YouTube? I guess I should. We put the problem of the day every day. We have a way that you can connect and go to there should you miss our show or should you want to see it again. Also, our Friday shows are there for you to enjoy. A little different there. It is www.youtube.com/Mathline. And you know, we're working on getting some streaming. Some of you may be actually trying to find us out there. We'll give you more information on how to get to that also. But we are trying to stream our shows right now. We're working on it. We're in test mode. If you happen to stumble across us and say, what? You're right. It's there. We're trying to get out there. We will make that more official as we get all our little bugs worked out, hopefully. But thank you for tuning in. Thank you for asking about us. And do we have a caller waiting for me? Okay, all right. Let's take a look at, hey, Mathline. I think we've got one waiting in the wings here. I think we have one waiting in the wings.
Hey, Mathline. I'm Riley from 4th grade in North Carolina. How much is 45% of 600?
Riley, hello from the Ripley's Aquarium. Oh man, we had such a great time up there. And this young man is from North Carolina, 4th grader. He has a quick question for us. Says, how much is 45% of 600? Well, I'll tell you something, Riley. If it had said 50%, I could just tell you right off the bat. 50% is half of that, which would be 300. And if I'd had 50%, I could basically say, oh, we just multiplied it and checked out, as we mentioned earlier with Emily, watch out for those decimal points. Because what happens when we change a percent to a decimal, we have to shift this little guy in 2 places. So here's one option. Here's one option for you, Riley. Then I'm going to do my little proportion moment because I like that. And teachers like to show that we do that because that's what they teach their students to do. And it makes sense because that way you don't mess up when it's not just straightforward like this. This is just pure old multiplication. So what I said was change that 45% to a decimal. And it's 45 hundredths. Notice that's, as we like to call it, 0.45. All right, the decimal's in front of your 4 and the 5, but it's 45 hundredths. And we're going to multiply that thing out. All right, so Riley, hang in there with me. We are going to get 3,000, first of all, because that's what happens when we run those two zeros, and 6 times 5 gives us 30. Now, we're going to shift that thing over, sort of like what we were doing with Emily there. She was saying add a 0. We're going to pull a 0 here. Sometimes we just leave that space blank. I'm going to leave it blank. It just means we're shifting, okay? Then we're going to do, wow, we've got to do another 0 for 0 times 4, another 0 there, and we've got to get, looks like, 24 going there. So what I'm seeing at this point, let's see, where are we going here, Riley? I'm seeing 27000, but remember we got to count 2 places, come in from the right. So it looks like 270 is what's going on there. Now, just to make sure we have done good calculations and stuff, let's try it on the calculator, see what we got there. I think we did good math on it. Sometimes we forget and don't show all these math steps, and I know our younger students are still needing to show their work on that and can't always resort to the calculator. We did get 270, and always make sure when you're dealing with the percent that you count the decimal correctly. Now, I promise those teachers who like the proportion setup, and I like it too, I really do. It's the part over the base equals the percent over 100. Remember we said about 45% is the same thing as saying 45 over 100 as a fraction, all right? And of course, 45 hundredths would also make sense as 45 over 100, right? And if you want to reduce that down, you could, but you really don't need to, especially with our good old great calculator business going on here. And plus the fact it's a lot easier to multiply by 100 or divide by 100 once we get rolling. So let's check this one out. Again, put the numbers in place. We have a part we don't know. It's what we're looking for. So we'll just put a little X up there or an N or whatever letter you want to put in there. Our base, where do we start from? And we know where that is. We're starting at 600. Now sometimes you'll be looking for that base. Sometimes you're trying to figure out where did we start from because you know where you ended up. You know you had 45%, but you didn't know what the total was or the base was where you started from. So in this case we do know that, thank goodness. And over here we've got 45 because they told you so. Right, there it is. There's your moment. There's your moment. By the way, sometimes the way you can tell the word, the number that's going to work with the base is the little word of. All right, so Riley, there we go. We're almost set up. I've got to put 100, don't I? Now at this point, lots of different ways we could look at it, but let's just cross multiply. And let's do those extremes. We've got 100x. In other words, we cross multiply. Let's go with those means. That's going to be 600 times your 45. We've already figured out what 600 times 45 is, I believe. It's going to give us, what is it going to give us? 600 times 45? I believe it's going to give us like 27,000. Woo! We already knew that 45 times 6 was going to give us 270. We got 2 zeros to accommodate, so that's how I knew that. Now let's put 100x over here. Back to Emily's question. I like the way some of these problems just happen to fit with what our callers say they need to know. This time we are dividing. Now she was multiplying, but this time we are dividing by 100. And when we divide by 100, we're getting things smaller. So this decimal is going to basically, or you can look at it this way, these 2 zeros are going to cancel right off there. And you know what? That's basically we shifted the decimal in 2 places. So we end up with, and by the way, the hundreds are gone here, so we end up with 270. So either way you want to do it, straight multiplication, because this is what we really did, right? We just set it up a little bit fancier here, so to speak. But the reason I like to have our students understand this part is sometimes they just think, oh, we multiply every time, and we don't. It depends on how the cross multiplication works, all right? So checking out, once again, we have the extremes here at 100 and x, the means at 45 and 600. My goodness, so much proportionality going on in the show today also. But there you go, 270 both ways. So Riley, thank you. And Ripley's Aquarium, we want to thank you all for having us up there this summer. It was a blast to come up and film some of your guests asking us questions, and we still got a few more to go through, and we had of all ages. This one was a young man, 4th grader, North Carolina, well represented. Thank you, Riley, and again, thank you, Ripley's, for helping us out there. Now, again, just a reminder, we are here live basically to help you out with math questions, help your students, help your children out, help your young people, help adults. We're here for anybody that wants to give us a call, all right? We love to talk with all ages and try to accommodate all learning styles and stuff like that, good things. Our number is 844-686-2378. If you haven't got that in your cell phone, put it in there for speed dial. We are on here the same time each day, basically 25, 26, 27 minutes, and we always have a little problem of the day, but you know, we get a lot of calls. We can shorten that problem of the day a little bit, and also, don't forget, problem of the week going on. But we want to hear from you, okay? So make the show rock. We want to hear from you all week long. We are, like I said, going to be live through Thursday. Friday, we do this thing called specialized segments where you don't get to call in, but we take a topic and we work problems together and let you work them along the way too. It's just a kind of a different style, different pace, but a lot of fun. And again, the best thing to do, keep tuning in with us. We love it when you do that. Check us Facebook, check us YouTube, check us on TV, be with us, like us, love us, and call us. We'll see you again next time.